Today we are going to find anions in our salt solutions. Anion is anything which has negative charge, minus, -1, -2 or something like that. So we have anions to identify today. In the test of anions, we have different type of reagents used for different anions. Unlike the test for cations, which have only two reagents to test, but in this case of anion, we have different reagents for different anions. So first of all, let us find out in the given table of anions how many different reagents can help us in the identification of any type of the anions present in. Number one, if we look at the carbonate and thiosulfate, in both of these anions, they are tested by dilute acids with H plus means dilute acid. So one of the reagent we need for the identification of anions is any dilute acid, let's say HCl aqueous. So this is one of the reagent. Second is the category where we have halides. So all the chloride, bromide and iodide, these are tested by the Ag plus aqueous. Ag plus aqueous, Ag plus aqueous. So these are the three Ag plus aqueous means this can be tested by silver nitrate, AgNO3, where Ag plus is available. They are further tested by the ammonia. We look for the precipitate's solubility, whether the white precipitates formed are soluble in ammonia, off-white precipitate forms partially soluble in ammonia, and yellow precipitates which are insoluble in ammonia. So AgNO3 is followed by NH3 aqueous. So this is for the halide, second reagent we need. Then we have two ions, nitrate and nitrite. These are tested by using sodium hydroxide or any hydroxide solution with the aluminum foil. So the two things we need here are sodium hydroxide and aluminum foil for the identification of nitrate and nitrite. So the last pair, the fourth reagent, is for sulfate and sulfite, in which we need Ba2 plus. With Ba2 plus means we need barium chloride or barium nitrate solution. So the fourth chemical is barium nitrate or barium chloride solution, because they are both in aqueous form. They are soluble salts of barium. So these are the four reagents we need for the testing of all the anions given in the table. Like these are the 9 anions. They are all can be tested by using these 4 chemicals. Okay, so in this experiment, when we have to perform the test for anions, we actually have to look at what is to perform and what not to perform, because not all the anions are tested by the same reagents as we have just said. So in this case, when we have a series of ions given, carbonate, chloride, bromide, iodide, nitrate, nitrite, sulfate and sulfite, all these anions needs to be tested. So we will perform only those tests which are not marked black. I have cancelled out all those which are marked black. These tests are not to be performed in the paper. Now, for example, if they give you Fa2, 3 and 4, these three to be tested with the 1 centimeter depth of a solution in a test tube, and we add silver nitrate. So we have learned that silver nitrate is used for all three halides. It means the possibility of halides in these three are possible. So now we will perform these tests. Then in the same test tube where we add this silver nitrate in these solutions, we will further add aqueous ammonia. And that aqueous ammonia is just for the solubility check, like if they are soluble, partially soluble or insoluble in ammonia, right? So we are starting with the first test, Fa2, 3 and 4, these three solutions of 1 centimeter depth, we will add silver nitrate and we will observe the color change. So we are testing this Fa2, Fa3 and Fa4 solutions which might contain halide ions because they have asked to add silver nitrate. So we will take 1 centimeter depth of all these three solutions. This is almost 1 centimeter of Fa2, 3, 4. So in all these three solutions, we will first of all add silver nitrate. Using a dropping pipette, we will add silver nitrate and we will see the colors of the precipitates. Now you can see white precipitates are forming in the Fa2 solution. Now in the Fa3, slightly off-white precipitates are forming. In the Fa4, these are the yellow precipitates forming, right? Now we will test all these solutions with aqueous ammonia for the solubility of these precipitates. So in this solution where we have taken Fa2, if we add aqueous ammonia, the precipitates dissolved completely, which shows that it's a chloride containing salt. In the case of Fa3, the white to off-white precipitates are not dissolving completely. They are getting lighter, means they are partially soluble, but not completely soluble. While in the case of Fa4, the yellow precipitates which formed at the top layer are not changing at all, which means yellow precipitates with silver nitrate, and in aqueous ammonia they are insoluble, means iodide ions are present in this salt. In the case of Fa2, we got white precipitates with silver nitrate, and those precipitates were completely dissolved in aqueous ammonia. So we'll write white precipitates soluble. And then Fa3, we got off-white precipitates which were partially soluble in aqueous ammonia. And in Fa4, we got yellow precipitates which remain insoluble in aqueous ammonia. So it shows Fa2 has chloride ion because white precipitates are completely soluble. Here we can see white precipitates with silver nitrate completely soluble in ammonia. In case of off-white precipitates which are partially soluble, it's bromide, Br minus. Since the table says for bromide, cream to off-white precipitates with silver nitrate becomes partially soluble in aqueous ammonia. And in the case of yellow precipitates which are insoluble, the anion is iodide because iodide shows yellow precipitates with silver nitrate as an insoluble in aqueous ammonia. The next test is for Fa5 and Fa6, in which we have to add aqueous sodium hydroxide in their 1 centimeter solution, and then we have to add aluminum foil and heat the mixture. And then what they are trying to find here is, if you look at nitrate and nitrite, these are the two ions which show liberation of ammonia. In both the cases, you can see this is the liberation of ammonia with sodium hydroxide and aluminum foil mixture. So how do we test the gases? We test ammonia by using a damp red litmus paper which turns blue because ammonia is slightly alkaline. So with Fa5, 1 centimeter depth, and Fa6, 1 centimeter depth, we will add sodium hydroxide. Now here is our sodium hydroxide. So we will add sodium hydroxide in both of these tubes. Sodium hydroxide, and this also sodium hydroxide. And now we will add aluminum foil in both of these. Here are the aluminum foils. We will add 1 aluminum foil in each of the test tube. And then we are going to warm these tubes one by one. So first of all, I am heating this Fa5 one. We will put this in the test tube holder. We will tight this by using this clip, and then we will switch on this Bunsen burner. So here is the Bunsen burner cork. We make it parallel to this clamp and the gas switches on. Now we are testing this with the moist red litmus paper. So we are first of all taking this litmus paper, and then litmus paper is turned damp by using this water. So if we add water here, it turns damp. And now this damp red litmus paper is used in this way. We put it here and we fold it from the side so that it will not fall. And now we will not heat like this because it will catch fire. What we will do is we will tilt this test tube a bit. We will tilt this test tube a bit so that this paper will not catch fire. Now if we are adding, we can see the aluminum foil is on the wall, so we have to dip this first. Now it's inside, and now we will heat this solution. As soon as we see that there is a gas coming out, what will happen? The gas must turn this moist red litmus paper blue from the center, from where it is open to the test tube. Now the gas, we can see, is liberating slowly. We do not heat this much that the solution comes at the top. No, we will remove heating. So if we heat and solution comes up, we will remove that, right? Now we will observe from the top that the solution is turning into a gas, that is if ammonia. The litmus paper must turn blue. So from here we can see the solution is liberating a gas that is slowly turning this litmus paper blue. Let's heat it further because the color blue is not clearly seen, but it's slowly coming. Now we can see the color is turning blue. So it shows the ammonia is liberated. We will do the same test with the second tube. So we will remove this. We will take the second one, which was actually Fa6 solution. Again, we will take one litmus paper. We will make it damp red litmus paper. Put this on a test tube, bend it from the corners, and then start heating up. Okay, so here in this case also, aluminum foil is not completely into the solution, so we need to make it go into the solution. Hold this paper so that it will not fall, and it is there in the solution. Now let's heat this. Now we can see that the color is changing with the gas bubbles given off. Make sure that the bubbles will not touch the paper, because as we have this sodium hydroxide solution which is already alkaline, so it will turn the red litmus paper blue by sodium hydroxide, because the sodium hydroxide is also alkaline. Make sure this solution will not touch this litmus paper. Now let us see the color of the litmus paper. From the opened exposed end, it turned blue. It shows that these two solutions contain nitrate or nitrite. Switch this burner off and let's continue with the further test. So in both of these Fa5 and 6 we got pungent gas that turned moist red litmus blue. Same with this one, pungent gas that turned moist red litmus blue. Now the problem is, if the both tests are showing this, we are confused with nitrate or nitrite. You can see both are showing the same test. Ammonia is liberating with the sodium hydroxide aluminum foil. Ammonia is liberated, sodium hydroxide aluminum. We are confused which one contains the nitrate and which one contains the nitrite out of these Fa5 and 6. So now, in order to confirm these two, we have to follow with the another test, which is for nitrite only. What is the test? The test is, if the solution contains nitrite, we can use this test also. That if we add acid, a colorless gas is given off which turns brown with air. Or we can also test it with the aqueous KMnO4, which is a purple solution, and it decolorizes. So I am going to perform these both for you so that you understand. Nitrite shows these two tests, whereas nitrate shows no results with these two tests. Now we are testing Fa5 and 6 to differentiate in between nitrate and nitrite. So first of all, what we will do is, we will take 1 centimeter depth of Fa5 and we will add acid to observe the gas, if colorless gas is given off or not. So now we will add in this solution equal volume of acid. So this is 1 centimeter depth, and then we will add 1 centimeter solution more. So if I have added 1 centimeter of solution, we can see there is no gas given off. Even on shaking, there is no gas given off, which means that it doesn't have nitrite. It contains nitrate 9, right? Now we will test the second solution, which is Fa6 for the nitrite. Again, we will take 1 centimeter depth of the solution and we will add acid in the solution, like 1 centimeter solution and 1 centimeter depth acid. So if we add 1 centimeter depth acid, we will observe the bubbles if they are given off. If we add equal volume, we can see that bubbles are released. If we shake it well, we can see the gas is gradually turning brown. And you can see from here, if we shake it well, the gas which is coming up is gradually turning brown. Look, the gas which is given off is gradually turning brown. So when we have added Fa5 in acid, there was no change. No gas was given off means no change. But once we have Fa6 added with HCl, it has given off colorless gas, and that colorless gas turned brown with air. Brown with air. It means it shows colorless gas is nitrogen monoxide, and it has given off nitrogen dye with air. So it shows that Fa6 contains nitrite NO2 minus, and this shows NO3 minus. Now we are going to differentiate in between Fa5 and Fa6, that is nitrate and nitrite, with one more test, and that is with aqueous KMnO4, potassium magnate 7. Now we are taking 1 centimeter solution of Fa5 in the test tube, which we have just tested that it contains nitrate. We will add aqueous KMnO4, and we have read that it doesn't affect the nitrate, and nitrate doesn't react with this KMnO4. So once we will add from the wall, so that we can see the purple solution is going in the tube. Now we see that there is no change of purple solution color, so it contains nitrate. Now we will perform the same test with Fa6. Now we will take this Fa6, which contains nitrite actually. So in this, we will add again this potassium magnate 7, same way from the wall. And we can see purple solution as it goes in the solution, it is changing its color. So you can see it is turning brown slowly. From purple, it turns brown. First of all, you can see the difference. And gradually, this brown solution will turn into white solution, right? So this brown solution will turn into white solution. If we add more Fa6, this brown solution will go down to colorless solution. So we will observe it. Now you can see the solution is turning to colorless gradually. Since the concentration is low, that is why more amount is needed to decolorize this, or else just the observation is purple to brown. It is again the right observation, purple to brown, and purple to colorless is again the same, right? Now the next test is with hydrochloric acid. We have to use Fa1, Fa6 and Fa8 to test with hydrochloric acid. Let me tell you first about this. Anions, what is the impact of acid on which of the ions? So first of all, if we look at the first one, carbonate, it gives off carbon dioxide when any acid is added. And carbon dioxide is a type of gas which in observation is termed as fizzing. Why? Because it comes out like a leather, like a bubbles, a cluster of bubbles. So leather is coming out. So we call it fizzing. And it can be tested by using lime water, which turns milky white. The second test with the acid is of nitrite. Why nitrite? Because it's not mentioned here, but if any acid is added to a salt solution containing nitrite ion, right here, what happens is a colorless gas is liberated. Colorless gas is liberated. Colorless gas turns brown with air. Now what is this? Because as colorless gas is nitrogen monoxide, when it gets air means oxygen, it converts into nitrogen dioxide, which is actually brown in color. So the colorless gas is nitrogen monoxide, which turns brown, that is nitrogen dioxide, with air because it oxidizes. And the third test is for thiosulfate. It gives off-white to pale yellow precipitates with acid. So when we add acid, three observations could be there for all these anions. Number one, it could be fizzing, which will be clearly seen as a leather of gases coming out. And for nitrite, it is a colorless gas which turns slowly brown with air, and yellow precipitates with any acid. So in this case of test, we add 1 centimeter depth of these solutions, Fa1, Fa6 and Fa8, and then we add hydrochloric acid. So let's perform that. Now we are going to test our Fa1, 6 and 8 with the acid. And the tests which are positive with the acid shows either carbonate, because it gives off carbon dioxide with acid, or it shows nitrite, as we have just seen, that gives off colorless gas that turns brown, and it could show you the off-white to pale yellow precipitate with acid of thiosulfate. So these are the three possible ions. Now we will test these three, Fa1, 6 and 8. In order to test for carbonate ion with the acid, what we do is we take our solution of Fa1 and then we add acid in this solution, and the gas which is given off must be passed through lime water in order to confirm whether the fizzing is of carbon dioxide or not. If carbon dioxide is given off, the lime water will turn milky white. So first of all, what we will do is we will take lime water in a test tube, and then we will put a delivery tube through this so that the gas which is given off must come from here and it will pass through this test tube content, which are calcium hydroxide lime water, and this lime water must turn milky white. Now we will take Fa1 and we will add acid. As soon as we add acid, we will put this rubber bung in this tube and we will see if the solution is turning white or not, right? So let us put this acid. So we have this acid being added to the tube, and we will quickly put this so that the gas given off must come to the other tube, and we can see that the solution is giving off a gas which is transferred to the other tube, and the content of the tube you can see are gradually turning white. It means the gas which is given off was carbon dioxide, and it shows that Fa1 contains carbonate ions. Now in the observation of this Fa1 with the acid, what happened was fizzing was observed, and when we have passed that gas through lime water, fizzing, that turned lime water milky. It shows that the Fa1 solution contains carbonate ions. So in this case we have carbonate confirmed. Now we are going to test our Fa7 and Fa8 with barium chloride solution, and then we can see there is a dotted line which shows that in the same content of this tube we will further add acid. Now have a look at this test in the table. This is for sulfate and sulfite, and the test is written in this way, that it gives white precipitates with barium 2+ solution, which could be barium chloride or barium nitrate, and again the same here, gives white precipitates with barium 2+ solution. Now in order to test those two white precipitates, we further add dilute acid which causes the precipitates to be insoluble, confirming sulfate, And if the precipitates dissolve soluble, it means sulfite is confirmed. Therefore, we are going to test this Fa7 and 8 with these two series of tests. Now we are taking Fa7 1 centimeter depth, and we will add barium chloride solution. We can see white precipitates are forming. Now we will confirm these white precipitates with acid. So now we will further add acid, and here is the acid. We will add this acid in order to see whether the white precipitates are soluble or not. So if we put acid here, enough acid, the precipitates are insoluble. It confirms that Fa7 contains sulfate ions. So in Fa7 with barium chloride solution, white precipitates formed, and those white precipitates in acid remains insoluble. White precipitates insoluble, which confirms that Fa7 contains sulfate ions. Now we will test Fa8. Now we will test Fa8 for the sulfite ion, because sulfate is confirmed in 7. So we will take the solution Fa8 1 centimeter depth, and we will add barium chloride or barium nitrate solution. And we can see the white precipitates are forming. And now what we will do, we will add acid, hydrochloric acid, in order to check whether the precipitates are soluble or not. So if we add acid, the precipitates are getting dissolved and the colorless solution is forming, which means sulfite ions confirmed. So white precipitates were formed with barium chloride, which remains soluble. Precipitates dissolve, which means Fa8 contains sulfite ions. So here we have the identity of all the anions present in the solutions confirmed. Fa1 contains carbonate, so anion present is carbonate. 7 and 8 contains sulfate and sulfite, so 7 and 8 contains sulfate and sulfite. And from the back we have chloride, bromide, iodide in 2, 3 and 4. So chloride, bromide and iodide in Fa4. And 5 and 6 contains nitrate and nitrite. So here we have nitrate and nitrite.